Hello and welcome back. Now today we're going to start with the final classification, which is steady and unsteady flow, and we'll close our classification. So thermocouples at all these points, and suppose initially this temperature at this point is 20, say 30, 40, say 20, 30, 40, something like that. Now the definition of steady flow is like that: a flow in which properties does not change with the time. So initially we see these are the values. After 10 seconds we see we have same values here, 20, 30, 40. From location to location it may be different, but with time it's not changed. Whatever it was at this time, after some time the values will be same everywhere. At initially at t is equal to 0 it was 20, after some time it will be 20 here. But initially it was 30 here, after some time it will be 30 there. It was 40 here, after some time it will be 40 here. So property value does not change with time. If the property values does not change with time, such a flow is called a steady flow. Steady flow. And any property, suppose whether it is temperature, whether it is pressure, so the properties in general does not change with the time, it's a steady flow. Now what is uniform flow? Uniform flow. Now uniform flow is when initially the value of the temperature was 20 everywhere, it is same everywhere, and which means the property value does not change from location to location, it is same everywhere. So after some time, after 10 seconds say, it will be 30, but it will be 30 everywhere. And then after another time, say 20 seconds, it will go to 40, but it will be 40 everywhere. Such a flow is known as uniform flow. So it is not steady, because with the time the properties are changing. It was 10, then 20, then 30. So with time it is changing. So it is not steady, it is unsteady. The opposite of steady is unsteady. It is unsteady, but it is uniform, because property values at an instant of time is same everywhere. So if a properties does not change with the time, steady flow. If properties change with time but does not change from point to point, location to location, is uniform flow. Now special case, a flow may be steady as well as uniform. Suppose initially the values were 30, 30, 30 everywhere. After 10 seconds, again 30, 30, 30 everywhere. After another time, again 30, 30, 30 everywhere. So property is not changing with time, so it is steady. The properties are not changing from location to location as well, so uniform. That will be a most simple case when a fluid flow is such that the properties does not change with time, and they do not change from location to location. We call it uniform flow as well as a steady flow. The opposite is unsteady flow. If property value changes with time, it was 20, then it is 30, then it's 40, it is changing with the time, it's unsteady flow. Now unsteady flow is the general term. It can be one term that in this general term, another subterm that we often use is transient flow. So transient flow is unsteady flow, and there's another term, for example, periodic flow. Periodic flow, both are examples of unsteady flow. So in these cases the properties change with time. But these terms that we use often in fluid mechanics is that suppose a flow is a laminar, internal flows are laminar for Reynolds number less than equal to 2300, and when the Reynolds number is greater than 4000, they are fully turbulent flows. But when the Reynolds number is changing from 2300 to 4000, the flow is transitioning from laminar to turbulent. So this transition range we called it transient flow. In this while this transition from laminar to turbulent flow, the properties change with time. That's why it is unsteady, subcategory of unsteady flow. But we use the term transient flow if the flow is transitioning from one form to another form, laminar to turbulent or incompressible to compressible. So it is transitioning, properties will be changing with time. Another term is periodic flow. If a flow is such that its properties are obviously changing, that's why it's unsteady, but they are changing such that they are oscillating about some mean value. Suppose temperature, so mean value of temperature is for this flow is say 30 degrees Celsius, and the flow is such that the temperature is continuously changing. It is sometimes going above 30, sometimes below 30, sometimes above 30. The temperature is oscillating about this 30 degrees Celsius. Or velocity, so there is some constant value of velocity, and the property, the velocity is now changing, that's why it's unsteady, but it is changing such that it sometimes goes beyond 3, sometimes lower than 3, so it is keep oscillating between this 3 meter per second. The flow is such that the properties keep on oscillating between oscillating about some mean value. Such a flow is known as periodic flow. So this was all about the classification of fluid flow, which we talked about 8 different types of classifications. So this will be all about this classification. Thank you.